Hi friends, in this video we see higher order ordinary differential equations. Right? Let us see that the general form of linear differential equation of order n is given by the equation number 1, which is d power n y dxn plus a1 dny dn1 minus dn minus 1y divided by dx power n minus 1 plus up to a and y is equal to f of x. This is the general form of higher order differential equation of order n. Okay, right. So where these a1, a2 and an are constant, and we can write d by dx as d by dx as for simplification we write d by dx as d, so it will become dny plus a1 d power n minus 1y up to a n y is equal to f of x, and you take y outside, the equation 1 becomes like this. This is we can call this a general form of simplified form of a higher order ordinary differential equation, HODE. Fine. Okay. This equation has the solution of this equation has two parts. One is complementary function, and the second one is particular integral. Any higher order differential equation has two parts. Solution has two parts: complementary function and particular integral. How to find complementary function and particular integral? That is the thing. Complementary function. If you want to find a complementary function, first what we have to do is replace d by m and f of x by 0. That is the first thing we have to do. In equation number 2, we have to replace, let us assume that d is equal to m and f of x is equal to 0, and substitute in equation number 2. So what it will become, you substitute m power n, right? M power n a1 m power n minus 1 up to am y, right? So that is equal to 0. F of x is equal to 0. So we get equation number 3. Now you see equation number 2 is differential equation. Equation number 3 is a algebraic equation of degree n. So degree of the equation is n. So it is very easy to solve the algebraic equation compared to differential equation. That we know. We know how to solve algebraic equation from our 8th standard onwards. Okay. So now algebraic equation has three types of solution. One is the roots may be equal, or roots may be different, or the roots may be complex. So the case one is if two roots are equal, right? Let us assume that we have two roots from the complementary function. If it is equal, those two roots are m1 is equal to m2 is equal to m, equal roots. We have two roots m1 and m2 which is equal to m. So in that case, the complementary function is y is equal to ax plus b into e power mx, right? Suppose in case 2, if all the roots are different, real and different, not complex, please remember, all the roots are real and different, then the solution is y is equal to a e power m1x first root plus b e power m2x. If we have third root, c e power m3x, like that it will go. In case 3, if the roots are imaginary, say we have two roots, one root is a plus ib and another root is a minus ib, means we can say that y is equal to, the complementary function is y is equal to e power ax, a cos bx plus b sin bx. This is the answer. This is the way we have to find a complementary function. Next we have to find a particular integral, right? So when we want to find particular integral, we have again two cases. When right hand side of the differential equation is equal to 0, that is f of x is equal to 0, means we don't need to find particular integral. That is the first point we must remember. When right hand side of equation is 0, no need to find particular integral. If right hand side of differential equation is not equal to 0, then we have to get particular integral. How we can get particular integral? It depends on the type of the problem. So Let us take type 1 problem. In this case, if f of x in the form of e power ax, this is a type 1. So there are 5 to 7 types. So each video I cover one type. So this is the first video. We have to start from here. In type 1, if suppose f of x is equal to e power x format, then particular integral is given by 1 by pi of d. Pi of d is our differential equation. I will tell how to solve all the things. That is into e power ax. In d, you replace d by a. Here, you replace d by a. If pi of a is not equal to 0, then that is the particular integral. Suppose if pi of a is equal to 0, what we have to do is, we have to differentiate e power ax. So if you differentiate e power ax, what we get is x into e power ax. Then the denominator will become 1 by pi dash of d, right? So differentiate the denominator also, pi dash of d. So otherwise you simply replace differentiate only denominator, multiply by x, e power ax. So this is another format. So again replace d by a. Provided if pi dash of a is not equal to 0, this is the solution. Suppose if pi dash of a is equal to 0, then again what you have to do, multiply the equation by x, so it will become x squared. Differentiate the denominator, pi double dash of a, e power ax, right? So the procedure may be little difficult for you, but when you solve the problem, it is the easiest one. Let us solve some problem, then you will understand everything very easily. Type 1 is very easy one. We should not miss this if they ask in exam. Let us solve the first problem. Right, solve d squared y divided by dx squared plus minus 4y is equal to e power 5x. This is the first problem. Right, let us solve the problem. First what I told, first write dy dx as d. So d squared, this simply, so d squared minus 4y is equal to e power 5x. What is the reason? D by dx is equal to d. Why I take it come? So first step, the solution has two parts. One is complementary function and another one is particular integral. When you want to find a complementary function, replace d by m. So d becomes m squared and replace right hand side f of x is equal to 0. This implies m is equal to plus or minus 2. Right, so it is two roots different. If the roots are different, what is the solution? Y is equal to a e power first root 2x, let us assume 2x, plus b e power minus 2x. What is the general equation? A e power m1x plus b e power m2x. m1 is plus 2, m2 is minus 2. Two roots, right? So I write like this. So this is the complementary function, right? Next, what we have to do, we have to find the particular integral. Particular integral is given by what you call y is equal, pi is equal to 1 by pi of d e power ax I told. So that is pi of d is nothing but d squared minus 4 into e power ax is our problem 5x. Right, so if you next what you have to do, you place d by a. So 1 by pi squared minus 4, it will become 1 by 21 e power 5x. This is not 0, so this is what our particular integral. So pi is equal to 1 by 21 e power 5x. So we got both cf and pi. The solution of the integration is y is equal to complementary function a e power 2x plus b e power minus 2x plus particular integral 1 by 21 e power 5x. Simple problem, right? So next problem, this is the answer. Okay, problem number 2. Let us solve this problem, right? So d squared plus 2d plus 1 is equal to into y is equal to 5. right? This is the question. Okay, here you see whether it is type 1 problem. Type 1 means right hand side should be e power format. So this one can be written as d squared by d solution. D squared by d, d squared plus 2d plus 1 into I is equal to, I can write 5 into e power 0x. So this implies a is equal to 0. That is also right? So in this format, so it is type 1. Type 1 means right hand side should be e power format. Now I have to find a complementary function. In order to find a complementary function, replace d by m. So m squared plus 2m plus 1 and substitute f is equal to f of x 0. So this implies m is equal to minus 1 minus 1. So we have two roots which are equal. If the roots are equal, what is complementary function? Y is equal to ax plus b e power mx. So m is nothing but minus, so e power minus x. So this is what our complementary function. Next, what we have to find? We have to find particular integral. Particular integral means this is equal to 1 by pi of d. Pi of d is nothing but d squared plus 2d plus 1 into e power 5 into e power 0x. Next, what we have to do? Replace d by a. So 1 by 0 plus 0 plus 1, 5 into 0 plus x, that is equal to 5. So the answer is not 0. So the denominator is not equal to 0. So it is pi. So pi is equal to 5. So what is our solution? Y is equal to complementary function ax plus b e power minus x plus particular integral is 5 over. This is the solution. Okay, so it is first one is equal two different roots. Now two equal roots. Next we see one more problem. If for complex roots we will see one problem. So let us solve. What is the question? D squared minus 4d plus 13 into y a power 2x. This is the problem. Right? If you want to solve it, first what we have to do to find the complementary function, it is right hand side is e power 2x, so type 1. So complementary function we have to find, replace d by m, so m squared minus 4m plus 13. Right hand side f of x must be equal to 0. If you simplify, what is the root we will get? We will get root as m is equal to 2 plus or minus 3i. So two roots, m1 is equal to 2 plus 3i, m2 is equal to 2 minus 3i. Fine. So if the roots are imaginary complex number, what is the complementary function? E power ax. So this is our a, this is our b. E power ax is nothing but e power 2x into a cos bx. B is nothing but 3. So a cos bx plus b sin b is nothing but 3x. This is what our complementary function. Particular integral the same format, 1 by pi of d. Pi of d is nothing but d squared minus 4d plus 13 into e power ax, 2a. So replace d by a. So 1 by 2 squared minus 4 into 2 plus 13 e power 2x. If you simplify, what you get is 1 by 9 e power 2x. This is what our particular integral. This implies solution is complementary function e power 2x a cos 3x plus b sin 3x and plus particular integral 1 by 9 e power 2x. This is what our solution, right? Okay, let me solve one more problem where the denominator becomes 0. Right, let us see this problem. D cube minus 3d square plus 4d minus 2 y e power x. We have to solve this problem, right? So first we have to find a complementary function. In order to find a complementary function, replace d by m. m cube minus 3m squared plus 4m minus 2. Replace f of x by 0. So this will become 0. When you solve this, what is the root you will get? M is equal to 1 or m is equal to plus or minus I. So we have three roots. It is a power degree of 3, so we have three roots, right? This is real roots. This is complex roots. So what is the for this? What is the for complementary function? Y is equal to, for real roots, a x a. It's a one root. Another root maybe we don't know. So it is a e power m1x. So a e power x. For this only a e power x. For complex roots, what we have to do? We have to add e power ax. This is our a, this is our b. Factor of I is b. So e power a is 1, so e power ax. A cos b, b is 1, so bx is 1 plus b sine. So here we have put a already, so we replace this by, b and c, right? We can just, it's a factor as a constant variable only, so we can put anything, b sine bx is x only, right? So for this, it is only one root. So a. So if you have two different roots, what is the formula? A. What do we write? A single root ax plus b e power mx. For two different roots, a e power m1x plus b e power m2x, we will write, no? So you use this. So e power m1x. So this is what our complementary function. Suppose next what we have to find is, we have to find particular integral. If you want to find particular integral, as usual, what we do, pi is equal to 1 by pi of d. Pi of d is d cube minus 3d squared plus 4d minus 2 e power x. Here a is equal to 1. So replace d by a. So 1 by minus 1 plus 4 minus 2. This is equal into e power x. This is equal to 1 by 0 e power x. If we get the denominator is 0, what we have to do? We have to multiply this equation by x and differentiate the denominator. That's what, x into 1 by pi dash of d e power x we have to find out. So pi dash of d, differentiate the denominator. D cube is 3d squared minus 3d, d squared is 2d, so 6d, 4d is 4 into e power x. Now replace this d by a is equal to again 1. So x into 1 by 3 into 1, 3 minus 6 into 1, 6 plus 4 e power x. So that will become 7 minus 6, 1. So x into e power x. Now denominator is not equal to 0. So this is what our particular integral. So what is my solution? Y is equal to a e power x plus e power x b cos x plus c sin x. This is what complementary function, and particular integral is x into e power x. This is the solution, right? So that's all about this session. I hope you understand everything clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.